More than 43 million people, or about 15% of the nation's population, rely on private domestic wells for drinking water. In Arizona, there are more than 100,000 domestic wells providing water to an estimated 120,000 households, or about 5% of the state's population. This video will show you the basic components of a domestic well-based water system. There are a wide range of water well system designs across Arizona. Water wells and the associated equipment across the northern portion of the state are typically enclosed for protection from the cold. In the southern portion of the state, most of the equipment can be left outdoors, as you will see in this video. Very shortly, we will be showing you an example of a properly sized and operating well. Here we have an example of a pretty typical domestic water well installation. See that the steel well casing is in place. It's at least 1 foot off the ground. The ground is sloped nicely away from the well to keep rainwater or anything else from puddling around it. It has a starter control box. This is what operates and manages the running of the motor and the pump in the well. And we have a disconnect here. I could just turn this lever down and that will shut the well off if I need to work on it or get into this electrical box. The plumbing from this well comes out of here and runs inside the building. The pressure control system and the bladder tank for this installation is located inside the building where it's safe, it's out of the way of the weather, and works nicely. Let me take you inside and show you the components. This customer's got a fairly typical modern-day captive air bladder tank. This is a bladder tank that holds air in the upper portion of it and the water comes in at the bottom. In this installation, we can see that the water comes in from this direction from the well and runs right past the captive air bladder tank and is controlled, the well's operation is controlled by this pressure switch. This turns it on and off at different pressure settings. From here, the water goes into this reverse osmosis filtering system and then goes on to the house. This customer has an additional added-on device that enables them to run their water well system off a portable generator in the case that the electricity goes off. Inside this panel, they have a switch to plug in a power cord that runs out to their generator, and they can run this in the event of a regional power failure.
Hi, I'm Patty. I'm a homeowner. This is my well. I wanted to make sure that in the event of a power outage, I was able to run my well using a generator. So to make sure I was able to do that, what I have done is I've posted instructions on how to do this, on how my particular setup works. I can come out here with a flashlight in the middle of a thunderstorm, get the power transfer all hooked up, put my generator outside, start it up, and I will be able to have well water. In the event the pump stops working, the pump installer has instructed me to come out to the starter control box and feel for the red button underneath, a reset button which you can push to get the pump going again. If you have to come out and do this many times, you probably need to call for service to have your pump looked at.
Patty's domestic well is typical of many private water wells that we see throughout our state. It was drilled by a licensed water well contractor, sized and equipped to meet her needs, and with her knowledge of operating her well and proper maintenance, it should last her for many years. Our thanks to Miss Patty Popp for assisting us with this demonstration of the components of a typical domestic water well in Arizona. This video is one of a series of 4 introducing you to basic aspects of your domestic water supply well. This video is the result of a collaboration between the University of Arizona Cooperative Extension Service, the Water Resources Research Center, and the Arizona Water Well Association. Funding was provided by the Water Sustainability Program of the Arizona Technology Research Initiative Fund, from the University of Arizona Superfund Research Program, and the Cooperative Extension Signature Program Initiative.